Hi everyone, my name is Dinesh Sarasena, and today I'm going to be sharing with you some of the basic physics behind ultrasound imaging. Ultrasound imaging is often described as the musculoskeletal physician's stethoscope. It enables us to do rapid, dynamic assessments. It's available both at the bedside and in the clinical setting, and it allows us to do interventions, particularly when patients are in need. Often patients ask me, what's the difference between therapeutic and imaging ultrasound? The therapeutic ultrasound is usually at much lower frequency, and the aim is to heat the tissue to have the therapeutic effect. Having had it done personally on pulled muscles and tendons, it's really quite a pleasant sensation. Imaging, on the other hand, is at a much higher frequency, and there's a lot more processing behind it to produce the images that we see on the screen. The core element behind the imaging is the transducer. Now, the transducer encompasses various elements which are important. Within the casing, there's going to be the power supply, there's going to be the piezoelectric crystals that both emit and receive the ultrasound waves, and there's also a variety of different insulating structures. The shape and the functionality of the transducer will depend on the purpose or wherever you're scanning. But essentially, this is the core sort of parts to the ultrasound transducer. So let's have a closer look at how ultrasound works. In the image here, the blue squares represent the piezoelectric crystals. When an electrical current is passed across these piezoelectric crystals, they emit sound waves, and this travels into the tissue. When these sound waves travel into the tissue and meet an interface, they're reflected back. And again, these piezoelectric crystals receive these signals, convert it into an electrical signal, which is then sent to the machine, and the machine does its processing to produce the images that we see. The image that we see will depend on the depth of the structure that we're examining, the nature of the structure, and also the type of interface that the sound waves are encountering. So let's take this situation. Let's say, for argument's sake, we have a hard structure within the tissue that we're examining. When ultrasound waves come and strike on it, it's going to get reflected back. And because it's a hard surface, there's going to be more sound waves bouncing back. As a consequence, it's going to appear bright on our image. Now let's say the same structure from the previous image is deeper within the tissue. The sound waves have to go further and have to come back a long distance as well. And as a consequence, what will happen is there's attenuation. So the surrounding tissue will absorb some of the sound wave energy. And as a consequence, while it appears deeper on our image, also it will appear darker because there's less signal coming back. An important phenomenon with ultrasound is when it meets a fluid interface. Fluid transmits ultrasound waves really well, and this is why we use ultrasound gel for coupling between the transducer and the subject. Fluid on an ultrasound image will appear black, and that's because the sound waves pass all the way through. But what you'll often find is that the distal end of that fluid structure will appear brighter, and that's because as the sound waves come and meet that interface, there's a sudden massive reflection of the sound waves back, and as a consequence it will appear brighter, and this is called acoustic enhancement. The final thing to consider with ultrasound imaging is when you meet an air interface. If there is air on the tissue that you're scanning, and the ultrasound waves meet it, they'll be absorbed and it won't be reflected back, and as a consequence you won't get a very clear image, or you may not see anything at all. It's similar to when you have your ultrasound transducer resting on the machine and you haven't applied the gel. You can't see anything on the image, and this is what you might find when you see air in the tissue. Well, that's the end of the talk. I hope you learned something that you can apply in your clinical practice. And if you did like the video, please remember to hit the like button down below. And if you want further updates, please subscribe to the channel. And I'll see you soon.